We are slowly getting into the nuts and bolts of generative AI or AI in general. We are continuing with more topics. Here we are going to learn about model lifecycle management. Then we are going to see the basics of how generative AI or a chatbot or an agent works behind the scenes and a lot more other topics. Without introduction, let's get into it. So again, different classification of data. So ML world and the AI world is all about data at the end of the day, consuming data and finding out different patterns inside the data. So what is this data? So it can be numbers, dates, text, images, sound, videos. Videos are nothing but connected images at the end of the day. It can be more than this: mathematical equations, proofs, papers, research papers. When I say papers, I mean research papers, books, pretty much combination of all these things, but has different value and accuracy levels. That's what this classification is about. Structured data. Data is often organized in the case of structured data, mostly in a database like RDBMS or JSON file format, some kind of specific format. Addresses of all the houses in a city in a table format or a JSON format is an example of structured data. Unstructured data, Wikipedia corpus is an example of unstructured data. Wikipedia corpus is nothing but the whole Wikipedia. You can search for Wikipedia corpus. There are so many places you can download free Wikipedia corpus. The whole information which is in the Wikipedia is free for download. It's around 50 terabytes of data, which includes images as well. But it's a humongous amount of text at the end of the day, which is unstructured data. And that's the example we are talking here, unstructured data. Data that lacks a predefined structure, can be anything, required sophisticated analysis. Then only we can make some sense out of it. For example, if you want to make a table out of all the Wikipedia entries, it's next to impossible. So they are very unstructured, random things. Quality of data. So that is another important thing, especially in these days where we have fake things in social media. For example, anyone can edit Wikipedia. They can put incorrect information into Wikipedia. Information from Facebook, Twitter, or X, all that kind of things are not really accurate. We need to find the accuracy of such information. They are not complete. They are incomplete information, consistent, and sometimes it is irrelevant. So such kind of information, while they could be unique and very informative, can be wrong. So the quality of the data matters. For example, a pretty old book on, say, for example, something like electromagnetism or general relativity. Those books, the accuracy level is pretty high. For example, the book called The Gravitation by Kip Thorne and some others. Probably that book is the gold standard for general relativity. So such kind of data is highly accurate. The quality is high. So that is another classification of data. Accurate, relevant, importance, all that kind of things. Accessibility. For example, I don't think Google can train their AI based on X data or the Twitter data because it's a different company owns the data. Same with Facebook or Instagram. Google cannot use that. It is not accessible to Google, although it is public. Similarly, Meta or OpenAI or any other company other than Google can access YouTube data. It is not accessible for them. Readily available, usable in proper format. Formatting is another thing. So that is a classification of input data based on this structured, unstructured, quality, and accessibility. Like I said, what is the importance of data here? Data is the most important thing when it comes to training an AI. More than often, it is the most expensive thing as well. When it comes to a model training, these days, most expensive thing is the hardware itself, the GPUs, hundreds of thousands of GPUs, electricity, all those things are the expensive things, but these are important factor as well to consider. Again, back to GenAI landscape. As you can see, I'm switching back and forth from different terminologies, and although they are related, they could have been a little more organized in this particular document. If I rewrite this document, I would do that, but This is the format of this document, the study guide we are going through. So we have to follow that because that is the order of the certification topics. So GenAI landscape. So GenAI powered application, what that means, it's all over the internet as well as the app stores these days. Remember, we discussed the model. Most of the model provided by the big companies are very foundational. They're very generic. They are used for specific purpose by applications. The model itself is very generic. It can do multiple things. It can do maths. It can do physics. It can do medicine. It can act like a doctor. It can act like a storyteller. Now, these applications, this GenAI powered applications, those are the one which is morphing these foundational models into a specific use case. Doctor, lawyer, retrieval augmented generation for an organization. All this specific application, we can tailor the generative AI. So that is what applications are all about. A lot of time, it is a chatbot in one way or the other these days, but agents are there these days with the MCP, the Model Context Protocol, are helping the agents to get things done. So the next point is agent. So what is an agent? Agent is normally does things. So let's get to the blackboard and explain what is an agent because it's an important topic. So agents in the context of LLM. So we have the large language model here. It could be Gemini, it could be OpenAI, any model out there. So this is the Gemini 2.5 Pro. So this is the model right here we have. And this is a laptop right here. This is a screen of the laptop which you're seeing right now. My laptop. So this is my laptop. Now, I'm sending a prompt to Gemini. And Gemini is giving me the most accurate result. 2.5 Pro is giving me the accurate result. This is text and this is also text. Now, I'm sitting here. This is me sitting here. Now, reading the text and doing something with that text. Let's say I'm asking, hey Gemini, how do I create a file in my C drive? How do I create a file in C drive? So that is the question I'm asking. So this is my prompt. And Gemini is giving me the steps. Step number 1, cd into C drive, execute the command, all the steps I'm getting from Gemini. But Gemini is not doing anything on my system. I have to do this myself. Read the instruction from Gemini and execute those commands. I have to do that manually. Now what the agent does is, agent does this particular piece right here, making me obsolete or take me out of the loop. So all I'm doing is, hey Gemini, create a file in my C drive. That is a prompt I'm giving. Gemini will give the instruction. The agent will read those instructions and execute on my system and create a file in my C drive. There is already a demo from me on the previous training. So we'll see that demo in this particular chapter in a subsequent lesson. I'm planning to do 2 demos. One is a model training demo, as well as I'm planning to do a MCP demo, a Model Context Protocol demo. Those are the 2 demos I'm planning to do. It is not part of the certification, but it's good to know how these things works behind the scenes. If you want, you can skip those demos, but I really recommend. Have a look at it. You don't have to understand any coding bit, but just understand this is how things works behind the scenes. It's not part of the certification, but agent is all about a program. So this is a program. What is an agent? Agent is a program which is running in the client side here on my laptop. Sometimes agent runs inside the model side as well. For example, you're asking the model to calculate 2 plus 3. It's very difficult for LLM to do this, 2 plus 3, for many different reasons. I'm not getting the details of it. Now, it's very easy for it to do it with a calculator. So calculator can be used. In fact, Gemini 2.5 Pro has tool access. It uses a certain tool to get answers. That's why it's so accurate. Gemini 2.5 Pro. So the agent can be this side as well to get things done and give the most accurate result to the user. Also, if it want to make some changes here or take some data from here, the laptop which I'm using, you can run the agents there as well. So that's the concept of agent. Agents does things based on the response from the large language model. Platform is explained by the APIs. So REST APIs, if you're new to REST APIs, they are nothing but like web pages, but they respond with JSON. Again, a platform to use these models like Gemini 2.5 Pro from a program, like a Python program, an automation system in a systematic way. That is what these APIs are all about. Almost all the tools, LLMs, agents, everything communicate through APIs, REST APIs. Now, the automation of data management, model deployment, all different functionalities to maintain and deploy the model is also available via the platform. If you look at my other training, AI 102, it's an explanation of a whole big platform in a cloud provider, just like Google has. Some of the things Google has we will be exploring soon in the platform session. The model we have seen. What is a model? Model is the most complicated piece in this whole thing. If the model is not good, we won't be talking about it like this. The model is what makes us different, and they are getting every day better. A complex algorithm trained on vast amount of data. Probably it's a bit of an underestimated statement, but that is what it is. But this is nothing but the brain of the whole thing. The weights and bias, the neural network itself. That is what the model is all about. So transformer-based model, that's what we are using for LLMs. It learns patterns and relationship, and it predicts the next token or the next output. So it does a lot of things: generate new content, translation, answer questions, pretty much anything human can do, a model does in a much faster, much accurate way. At least that's what we are targeting. Infrastructure, this is where the most expensive things comes, other than the data, of course. The GPUs and TPUs and all different parallel computing infrastructure. The hardware required to train these models, because they are pretty big, they are large, they are very large language models. Billions of parameters, multi-billions of parameters, if not trillions, which needs tons of TPUs and GPUs. That's what the infrastructure, only big companies has that kind of infrastructure at the moment. Google, Microsoft, Amazon, those are the companies which has the infrastructure. Most of the GPUs are made from a company called NVIDIA these days. H200, A100, all these are different expensive graphics card used for training the AI. Running all those algorithms we have discussed, the backpropagation, optimizing the cost function, they are all nothing but matrix multiplication, multiplying two numbers, two decimal numbers. It boils down to that at the end of the day, and billions and trillions of calculations like that on petabytes of data. That's where all this infrastructure comes into the picture. Now, the ML lifecycle, that's what we're going to discuss next. How a model is created, trained and deployed and improved over a period of time. This is also called MlOps, and this is kind of the diagram which shows how the MlOps is performed. Let's get into the blackboard and let's try to understand what this is all about. So model lifecycle. So everything starts from a neural network, assuming that we are using deep learning for this particular example. This can be applied to any machine learning model, pretty much any code which does any prediction for the matter in general. It is also called MLOps, this lifecycle, machine learning operations, just like DevOps, continuous integration and continuous deployment, more or less. So in this case, we are taking the example of a neural network. So you have the model right here with all the neurons inside it. It has all the weights and bias, all the numbers, pretty much all the combination is in random order because it's a start. Now what we are doing, we are training this thing using data. So the training happens and we give the backpropagation and this model gets trained. And one important thing to mention here is that this is running in a very expensive hardware, at least for the current setup. H200, A100, all this kind of GPUs are being used. It's a very expensive hardware. The training happens in a very expensive hardware. Hundreds of thousands of this. GPU, TPU, all kind of very specific hardware. These are NVIDIA chips. Because of these chips, NVIDIA share is going pretty high, as you can see. But these are very expensive hardware. So once training is done, this whole thing is saved in a file and moved across to a deployment platform for inference. Inference is the purpose or the use of the model. So inference or prediction is the purpose of the model. Now, why we are moving into a different hardware? Because the training needs a higher quality hardware, while inference needs very less amount of hardware. Or we can run inference in less compute or reduced compute. So this is the inference or prediction, whatever you like to call it. Basically using the model to predict an output given an input. For example, a prompt. So we are giving prompt and it is giving the response. So that is inference. Now the model is the same model which we have trained. That's the model right here. There is no difference. It's all the neural network. Now we have found a problem. We have given a particular input and the model is giving jargon. Very bad. The model is not behaving correctly for a particular type of input. Counting the words in strawberry. It is telling that it is 2 sometimes, it is sometimes 4. That kind of problem we are experiencing. Now we want to retrain the model. So we have taken this data, which it is causing the problem, and we have taken the output, which it is giving, and we are telling the model, we need to retrain the model or fine-tune the model such that the output is the desired output. So for the training purpose, we are getting the model back to the training platform, that expensive hardware. Now we have given that output and input into the model for training purposes. And again, we are bringing the model back to the deployment. So this is the deployment. So deployment of the model so that we can use it for inference. This deployment can be in multiple different environments like dev, test, UAT, and finally production. I'm not going to the details of such things because it's slightly outside the context of this particular training. But typical MlOps has other environments as well to test the model in a proper environment after training. But in this case, we are simply deploying the model and running. Now, this is the transformer architecture. Now there is a better architecture has come up. There is a better fine-tuned approach for the transformer. The model is to be changed. So the new model is coming up. Thinking model with the reinforcement learning, like the O series in OpenAI, the latest Gemini series, all are thinking models. So the model is changing. Again, the same process. We change the model, we train it, and again deploy. Again, finding out problems, retrain, deploy. So this cycle goes on. This is the life cycle of a model or MlOps. Any change is getting deployed for inference. And then from the inference, if there is any issue, it is getting fixed. If there are any changes in the model without any issue, that is also getting deployed. Now, getting back to this diagram, I'm pretty sure this is what they meant by this circle right here, the training and retraining and deployment. So data ingestion and preparation. So data we need to clean and label and all that kind of things we need to do, making the data ready, and training using expensive hardware at this point in time, like the one we discussed, the NVIDIA graphics card and things like that. And then finally, deploy the model. We need less compute for this, less intensive compute, and then model management. Finding out if there is any issue, if there is any jailbreak, is there any wrong answers, hallucination, all these things is managed here. And based on the output and input, we are retraining the model and doing this cycle again. So that is the ML life cycle. So we have seen a lot of different types of data types and related topics, as well as we have seen the generative AI basic working, how a model communicates with a client, etc. As well as we have introduced model lifecycle management, which is the basics of ML operations or MLOps in short. Let's continue our journey in the next lesson, and thank you for watching.